8086 microprocessor instruction set. 8086 supports 6 types of instructions: data transfer instructions, arithmetic instructions, logical instructions, string manipulation instructions, processor control instructions, control transfer instructions. Data transfer instructions. Instructions that are used to transfer data or address into registers, memory locations, and I/O ports. Generally, it involves two operands, source operand and destination operand of same size. Source, a register or a memory location or an immediate data, and the destination have two possibilities, a register or a memory location. The size should be either a byte or a word. 8-bit data can be moved to 8-bit register or a memory, and a 16-bit data can be moved to 16-bit register or a memory. Data transfer instructions. The first data transfer instruction is move. Move is an instruction which can be copies a 16-bit data or 8-bit data from source to destination. There are 5 possibilities of operands. If the source operand is a register and destination must be a register or a memory location. If the source operand is a memory, and there are one possibility, that is the destination must be a register. If the source is a immediate data and the destination have two possibilities, that is either register or a memory. Exchange. Exchange is another data transfer instruction which can be used to exchange the data between source operand and destination operand. If the source is a register and the destination have two possibilities of register and a memory. The next instruction is push. Push instruction is used to push the contents of a register onto the stack. And the main important note of this push instruction is the push instruction can hold only 16-bit register or a 16-bit memory. That is push register which is having 16-bit and push from the memory location. Whenever it is push instruction is executed, the stack pointer is decremented by 2 and the contents of stack segment is added with the contents of a stack pointer in order to get 20-bit exact address. Next, pop. Pop instruction is used to pop the contents of the top of the stack by incrementing the stack pointer by 2. In and out instruction. In a comma in the braces dx is a IO indirect addressing, in that the content of the dx register is moved into AL register in a comma address 8, that is in that the 8-bit address is called as a port address. The content of that port address is moved into AL register. One important feature in this in and out instructions are the data must be present in the accumulator AL or AX. Same like out instruction. Out instruction is we can send the data from accumulator to output address. Whether it is a 16-bit or 8-bit. If it is a 16-bit, we can use indirect addressing. If it is a 8-bit, we can use directly on the instruction. Next, arithmetic instructions. In that, the first instruction is add. The add instruction is used to add the two numbers from two operands. There are, if the source operand is a register and the destination operand may be a register or a memory location. If the source operand is an immediate data, we can have two possibilities of destination operand, that is either a register or a memory location. If the source operand is a memory location, there is only one possibility, that is the destination must be memory. If the source is a memory and destination must be register, the destination operand should not be immediate data, should not be a memory. Memory to memory is not at all possible in 8086 microprocessor. Example, add AL comma immediate data, 8-bit immediate data. The content of AL register is added with the 8-bit data indicated in the instruction and the result is updated in the AL register. ADC, add with the carry. In this, addition operation is done along with the carry flag. If the source operand is a register, two possibilities of destination operand, that is either register or memory. If the source operand is the immediate data, there are two possibilities of destination operand, either register or a memory. If the source operand is a memory and the destination must be register but not a memory location. Example, ADC AL, date 16-bit data. In this, the content of AL and immediate data 8-bit and the content of carry flag is added and the result is updated register. SUB. SUB is the subtraction operation which performs subtraction between two registers, that is two operands. If the source operand is a register, there are two possibilities of destination operand, either register or a memory location. If the source operand is a memory, there is only one possibility of destination operand, that is a memory register. If the source is the immediate data, there are two possibilities of destination operands, that is either register or a memory, but not a immediate data. Why? Because if the source is a immediate and destination should not be immediate. If the source is a memory and destination should not be a memory. Sub a comma immediate data. The content of AL is the 16-bit or 8-bit data is subtracted from the AL or AX and the result is updated in the destination register AL and AX. SBB, subtract with borrow. Same like add with carry. Here, the carry flag is subtracted from the next result. SBB, source operand, destination operand. If the source is a register, destination is also register. If the source is a memory, destination is a register. If the source is a register, destination is a memory. And if the source is a immediate data, destination may be a register or a memory. Increment and decrement. Incrementation and decrements is incrementation means adding +1 to the register content or a memory content of a memory. Decrementing means subtracting -1 from the content of a register or a content of a memory location. Mul instruction can perform the multiplication operation between two registers. And one important note, at this multiplication instruction has only one operand, that is the source operand, and the default destination is accumulator. If the source is a register, destination is a register. If the source is a memory, destination is a memory. For example, if we are performing a byte multiplication, the result is stored in AX. If, for example, if we are performing word multiplication, the result is stored in both DX and AX registers. IMUL. IMUL is an instruction which is used to perform signed multiplication operation. That is IMUL register or IMUL memory. And the default destination is a register, that is accumulator. Div. Div is an instruction which is used for division operation. Div is for unsigned division. Div register or a div memory, and the default destination is accumulator register. If, for example, if we are performing 16-bit by 8-bit division, that is AL by AX by AL, then quotient is present in the AL and remainder is present in AH. If we are performing 32-bit by 16-bit division, the quotient is present in the register and the remainder is present in the DX. IDIV. IDIV is for unsigned division. In order to perform the division between two signed numbers, we are going for a IDIV instruction. IDIV register. In that, the 16-bit by 8-bit division will perform and quotient is stored in AL and remainder is stored in AH. If we are performing 32-bit by 16-bit division, quotient is stored in AX and remainder is stored in DX. If IDIV memory means the content of a memory is divided with the content of accumulator and quotient is stored in AL and remainder is stored in AH. If we are performing 32-bit by 16-bit division, quotient is stored in AX and remainder is stored in DX. Comparison instruction. Comparison. CMP is a comparison instruction which can be used to compare between register to register, memory to register and register to memory. And whenever the register to content of register 2 is greater than content of register 1, then carry flag and zero flag and sign flag are reset. If the register 2 content is less than register 1 content, then carry flag is 1, zero flag is 0 and sign flag is 1. If the register 2 content is equal to the register 1 content, then zero flag is updated and remaining are not updated. insertion AL comma data 8-bit data. If the content of AL is greater than the immediate data, then there is no change in the remaining registers. If the content of A remaining flags, if the content of AL is less than the immediate data, then carry flag is equal to 1, zero flag is equal to 0, sign flag is equal to 1. If the AL is equal to the immediate data, then zero flag is equal to 1 and carry and sign is set to 0. Div is an instruction which is used for division operation. Div is for unsigned division. Div register or a div memory, and the default destination is accumulator register. If, for example, if we are performing 16-bit by 8-bit division, that is AL by AX by AL, then quotient is present in the AL and remainder is present in AH. If we are performing 32-bit by 16-bit division, the quotient is present in the register and the remainder is present in the DX. Or if any one of the input is uh, uh, if any one of the input is high, the output is high. If the source, it can have two inputs. If that should be stored in two operands. If the source operand is a immediate data and the destination operand have two possibilities, that is either register or a memory. If the source operand is a register, there are two possibilities, either memory or a register. If the source operand is a memory, there is only one possibility, that is register, and the result is always stored in the destination operand. XOR operation. In if there is odd number of ones, the it is set, and even number of ones, it is reset. If the source, it is also done between two operands. If the source is a register, destination is either register or a memory. If the source is a immediate data, the destination may be immediate data. The destination may be register or a memory. If the source is a memory, destination must be register, and always destination operand is modified with the result. XOR A comma data, XOR AL comma 8-bit data. The XOR operation is done between the content of AL and immediate data in the instruction, and the result is updated in the AL register. Test is used to test for weight input to go low. Test register 1 comma register, test register comma memory, test memory comma register. Shift right. The shift operations are supported by the 80886 microprocessor, shift right and shift left. Shift arithmetic right and shift arithmetic right. When coming to the shift right, the shift right register comma count. That means that count indicates number of shifts. That count is generally placed in the CL register. SHR register comma 1 or SHR register comma CL. In the shift right operation, the one bit is shifted by right by one position and MSB is inserted with 0. If we are performing shift left operation, means the content of a register or a memory location is shifted by one position left, and the least significant bit should be inserted by 0. In the shift operations, every time when we perform shift right operation, MSB is inserted by 0. When we perform shift left operation, LSB is inserted with 0. Rotate operation. Rotate right through carry. In this operation, rotate the carry flag plays a major role. Rotation means the contents of if the contents of a register or a memory is rotated one bit position right, and that is moved into carry flag, that shifted bit is again added and into the MSB bit. There is no extra bit added in this. Within the data itself, it is rotated, added. ROL means rotate left without any carry. That means rotate left The content of a memory or a content of a register are rotated left by one bit position. That one position left bit is again added at the LSB bit. String manipulation instructions. String is a sequence of bytes or word. 8086 instruction set includes for string movement, comparison, scan, load and store operations. Repeat is the instruction prefix which is used to repeat execution of a string instructions. String instructions ends with S or SB or SW. S represents string, SP means a string byte, SW means a string word. Offset or effective address of a source operand is stored in SI register or the destination operand is stored in DI register. Depends on the status of the direction flag. SI and DI registers are automatically updated. If the direction flag is 0, SI and DI are incremented by 1 for byte and 2 for word. If the direction flag is set to 1, SI and DI are decremented by 1 for byte operation and 2 times for word operation. REP, repeat if 0, repeat if equal. Repeat while Cx is not equal to 0 and Zf is equal to 1, repeat the execution of an instruction and Cx is decremented by 1. Repeat non-zero, repeat if not equal. Repeat comparison, compare string and scan string until 0 flag is equal to move string byte, move string byte, move string word, move string. This instruction can be used to to move the strings from byte strings or word strings from source location to destination location. The source is present in the SI register and the destination is present in the DI register, which can be added with the segment addresses. Data segment refers to SI and extra segment refers to DI. In order to calculate the 20-bit physical address, compare string. Compare two string bytes or two string words. The content of a SI is compared with the content of DI, and whenever we are performing the comparison operation, if the state based on the status of the flags, we can perform the comparison operation. Scans or a string byte or string word with accumulator. The scanning means each and every string bit is scanned with the content of accumulator. If the content of accumulator can be stored, for example, SCASB, move AL comma dollar. If the string have a dollar, it can scan each and every byte until that dollar symbol will be equal. If the df is equal to 0, then destination index is di plus 1. If the df is equal to 1, then di is di minus 1. If we are performing scan operation for word, then di is if the df is equal to 0, then di is incremented by 2, and if df is equal to 1, it is decremented by 2. Load string by into the AL or string word into the AX register. We need to load any string onto the AL and AX register. Then we can use load as LOD SB or LOD SW instruction. Store string byte from AL or word from AX into string. We need to store the contents of AX and AL register onto the string. Then we'll go for store string byte and store string word. XOR operation. If there is odd number of ones, it is set, and even number of ones, it is reset. If the source, it is also done between two operands. If the source is a register, destination is either register or a memory. If the source is a immediate data, the destination may be immediate data. The destination may be register or a memory. If the source is a memory, destination must be register, and always destination. Control transfer instructions. Transfer the control to a specified destination or a target. Instructions it does not affect the flag. 8086 have unconditional transfers like call, return and jump. Call instruction is used to call the subroutine instruction. RET instruction is a return instruction which is used to return to subprogram to main program. Jump instruction is unconditional jumps to various locations within the control transfer instructions. Signed control conditional branch instructions, unsigned conditional branch instructions. G, jump if equal, jump if not equal, jump if greater than or equal, jump if less than or equal, jump if not greater than, jump if not greater than or equal, jump if less than, jump if not less than or equal, jump if not zero, jump if the result is zero. These conditional branch instructions can be used to check the result of previous instruction. If the previous instruction satisfies the condition, then the jump operation will perform. If the previous instruction result will not satisfy the condition, it will execute the sequence, normal sequence. G. J, jump if equal, jump if not equal. These are also unsigned conditional instructions. 8086 conditional branch instructions affecting individual flags. JC, jump if carry instruction affect the carry flag. JNC, jump if no carry. If the jump will occur when CF is equal to 0. JP, jump if parity. Parity flag is equal to 1. Jump if no parity. If the jump if parity is equal to parity flag is equal to 0. Jump if overflow. It happen only when overflow flag is equal to 1. Jump if not overflow. It happen when OF is equal to 0. Jump if signed. Then when SF is equal to 1. Jump if not signed. Then if SF is equal to 0. Jump if 0, if the result of previous instruction is 0, that is ZF is equal to 1. If jump if no 0, if the previous instruction result is not is equal to 0. Instructions to the assembler regarding to the program being executed. Control the generation of machine codes and organization of the program, but no machine codes are generated for assembler directives. These are also called as pseudo instructions. These are used to specify the start and end of the program, attaching value to the variable, allocate storage locations to the input and output data, and which are used to define start and end of the segments, procedures, macros, etc. DB, define a byte type variable. It reserves specific amount of a memory locations to each variable. Range is 00 to FF, 00 to 7F, 80H to FF. Unsigned value, positive value and negative value. In general form is list DB 7FH, 8042H, 35H. Three consecutive memory locations are reserved for a variable list and each data specified in the instructions are stored as the initial value in reserved memory locations. DW, define word. Define a word type variable. It reserves two consecutive memory locations to each variable. The range is 4 zeros to 4Fs for unsigned value, 4 zeros to 7 triple F for positive value, 8 triple 0 to 4Fs for negative value. For example, A list DW 6512H, 0F251, 0CDE2H, 6 consecutive memory locations are reserved for this variable A list because each individual location will store only 8-bit data. In order to store 16-bit data for one input, it requires 2 locations. In order to store 3 16-bit inputs, it requires 6 memory locations. Segment. Segment is assembler directive which is used to indicate the beginning of a code, data and stack segments. END is an assembler directive which can be used to express the end of the segment. General form is segment name with segment and segment name with ENDS. Program start and program. Assume. Assume is assembler directive which is used to inform the assembler the name of the program or data segment that should be used for specific segment. Assume segment register, segment name, segment register, that means assume CS code, DS data. That means data is a segment which refers to the data segment and code is the name of the code segment. Assume CSA code DSA data tells the compiler that the instruction of the program are stored in the segment A code and the data is stored in the segment A data. ORG is used to assign the starting address for the program and data segment. END is an assembler directive used to terminate a program. The instructions after the end instruction should not be executed by the processor. Even informs the assembler to store program or a data segment starting at even address. Whenever we'll put even, it will start the addressing always at even address. EQU is an assembler directive which is used to attach a value to the variable. ORG 1000H informs the assembler that the statements following ORG 1000H should be stored in the memory location starting with effective address 1000. Loop EQU 10 The value of the variable loop is assigned with 10 FEH. As a segment is data in this data segment, the effective address of a memory location assigned to A will be 1200H and that of B will be 102, 1202 and 1203H. Proc is the assembler directive which indicates the beginning of the procedure, and ENTP is the end of the procedure. For intersegmenting call, near intrasegment call. Add 64 proc near is a subroutine procedure name. Add 64 is declared as a near procedure, and so assembler will code the call and return instruction involving in this procedure as a near call and return. Jump short ahead. Short is assembler directive which reserves one memory location for 8-bit signed displacement in jump instructions. Example, JMP short ahead. The directive will reserve one memory location for 8-bit displacement named. Macro is an assembler directive which indicates the beginning of a macro. ENDM is the end of a macro. The general form is macro name, comma, arg1 and arg2. Macro name ENDM. It is called as a defining a macro. That means the macro should be defined with the name called macro with the macro name, and it is ended with ENDM, that is end macro.